Okay, hi guys, how are you? I hope you are very well. And today we want to continue our discussion about air valves. If you remember, before we completed the basic level for air valve training, and after that, we started in last session in advanced level training, and now we want to continue advanced level training, and I will share a lot of information about design and how can design air valve in under all of these type of the air valve. Okay. Last videos, if you see it, please, if you don't see, please go there and check, and once see it and then come to these videos. It is better for you for better understanding. That video we discuss about air release valve, and for a small amount of the air inside the pipeline, but now we are reaching to this point whenever pipeline inside the water of the pipeline we want to drain, fill it or drain, both of them it's same, but now I discuss and I more explain about filling water inside the pipeline, and how can calculate and how can do sizing for that type of the air valve and which type we need to use. Purpose let out large amount air valves during pipeline filling, because whenever you want to fill inside the pipe, we have a lot of large amount air, and we need to release all of this amount of the air, and for this reason we need to put proper air valve. For example, we need to put vacuum valve or combination air valve. Both of them can use for this purpose, and air type, it will be high volume and rapid flow. Rapidly it will be fill. And what is the condition during a startup, during pressure test, and in after shutdown? We need to use this type of the valve, and we need to filling water inside the pipeline, and then all of these things for design and sizing will come. Okay. Orifice sizing for pipeline filling. We have key considerations. The first of all, we need to know air must be vented at the same rate the pipeline is filled. It means rate of the air. Whenever you fill water, rate of water and rate of the existing air from the pipeline, it should be same. And also recommended filling velocity, it is 0.3 meter per second. And typically venting pressure differential, it will be between 2 psi for standard valves and 5 psi for a slow closing valve. Assumption: valve at sea level and air temperature, it is 15.5 degrees Celsius, and also we need to assign compressible adiabatic flow. It means air inside the pipe, we need consider it is compressible and it is adiabatic, because we need to use some formula and equation based of these two things, and use discharge coefficient CD. This is 0.7 we need to consider. And we have one equation and calculation. We can easily calculate rate of the airflow. Whenever you fill water inside the pipeline, from other side, same amount the air it need go out. Sorry, it's not same. You need to calculate by this equation. Here Q is flow rate, air flow rate, and unit is SCFM. This Q, a small q, is fill rate gallon per minute. This is water flow rate, and we have delta P here. This delta P, it's differential pressure. At a normal, we consider 2 psi. This is the standard. If I give you one information, as I said before, if this differential pressure between inlet and outlet of the air valve, air pocket coming from inside the pipeline and go inside the valve body, and this is the inlet. Outlet, it means that amount of the air goes out from orifice. This is the outlet, this is the inlet. If differential pressure between inlet and outlet, it will be 2 psi, it is the standard, and if it is it will be 5 psi. I told it is a slow closing, and if it will be 28 psi, we have sonic, and that time if you increase the pressure, flow rate, it will not change at all. This is the things you need to consider for your design. Step 2, after calculation this formula, and when you reach to ventilating flow rate for air, and then you need to refer to table as per our discussion in last videos. We need to go to that table and that diagram, and we have differential pressure. We have pressure. We have air flow rate, and then we can find size of the best the size of the orifice. I give you one example and then you understand better. Okay, example. Consider you have one pipe 66 inches diameter, and we are filling inside the pipeline, and flow rate is 10,500 gallon per minute. Velocity of the water filling is 0.3 meter per second, and air valve designed to release air at a pressure of 2 psi. It means it is the standard. Okay. Now we need for finding the best and best selection for size of the orifice. The first we need to calculation air flow rate. Here we have that equation. Only we put all of this number in example. Here flow rate, water flow rate, 10,500 gallon. Here we put that one, and also delta P is 2. If put all of this data inside, we reach to this point, 1,598 SCFM. This is the air flow rate. Now we need to refer to that table, this table. If you see, pressure is 2, okay, this is 2 pressure, this column is pressure, and this row is orifice diameter. This is the inch, and all these things, it is the capacity of the air flow rate. Okay, now pressure is 2. We go direct. What was our air flow rate after calculation? 1,500, around 1,600. Okay, here if you go front and follow this line, it will be between 1,000 and 1,780. Okay, we choose this near to this, that flow rate. Whenever reach to this point, you go vertically and reach to this point, 4. It means orifice diameter, it will be 4. Very simple. Okay, here also mentioned at 2 psi 4-inch orifice is suitable. Okay, and this diagram also, it is the same. It is same. You can use this one or that one. You reach in the same point. Okay. Sizing of orifice during draining pipeline. What is the purpose? let air in to avoid vacuum or collapse during draining. During draining, uh, backside of the water vacuum it will be created, and this vacuum it will be very dangerous and can collapse pipe, and for this reason we have to choose air vacuum valve or combination valve in proper and suitable location. When this activity happened, when you want to do maintenance or in emergency shutdown, both of this activity you have draining water from pipeline, and definitely you face to this problem. Okay. Okay, for sizing we need to know objective sizing requirement and recommended draining rate and additional notes. For sizing requirement, we need to install air valve at the high point near draining zone, and valve must admit air at same volumetric rate as water draining from pipeline. And also recommended draining, we need to consider for design drain velocity, it will be 0.3 to 0.6 meter per second, and controlled rate minimize water hammer and pipe stress. Okay. For gravity, also we have sizing for gravity. What is the purpose? Handle air in gravity system, for example for sewer lines, and air type it will be moderate volume, dual direction, release and intake, and also typical valve it will be combination air valve or air release plus vacuum valve, and operating condition it is low pressure low. Okay, and sizing in special application purpose for challenging or non-standard conditions in highly corrosive or gas-laden fluid, okay. Last subject for this video regarding sizing of the orifice for special application. What is the special application for challenging or non-standard condition for highly corrosive or gas-laden fluids, extreme pressure or temperature, intermediate or revise flow, uh, reverse flow, and approach custom engineering. Maybe in this application we need to uh, uh, analyze by CFD simulation or field data analysis. Okay, guys, I hope you enjoy and you learn some things about design of air valve during filling and draining uh, of pipeline, and for gravity application, also for special application. We discuss about all of them, and I hope you enjoy uh, about this subject. And if you like my videos, sorry, please uh, follow me. And I have other videos. I think for complete of this air valve, I need 2 3 maybe more videos only for these topics, and I will share all of my experience and knowledge about that. If you have any question, please drop your comments. I will read it, and as soon as possible I will reply you, and I will appreciate if you like and subscribe my video channel. Okay, see you next time.